Okay, today we've got more related rate questions. And the ones today are, maybe going to be a little more complex, or they might have, kind of a second layer of analysis you have to do before we can get the answer. But they're going to pretty much work the same way. So a lot of the ones today are going to have, maybe some kind of proportionality relationship, or will go from the surface area of a sphere up to the volume, down to the radius, kind of moving back and forth. Okay, the first one we've got a cylinder, and it's losing water at a rate of 10 cubic feet per minute. Okay, so dV dt is negative 10. If the radius is 10 feet, what is the rate of change of the height of the water? Okay, so we want dH dt equals what? Okay, well, I've got the volume of a cylinder is going to be the area of the base multiplied by the height. And they said that the radius is constantly equal to 10 feet. And so this is now EV is 100 pi h. So the derivative of V with respect to t is 100 pi dH dt. And then, okay, we know that dV dt is negative 10 is 100 times pi times dH dt. And we could solve for dH dt, which is negative 10 over 100 pi. Okay, h is going to be measured in feet, and time is measured in minutes. Okay. And, this one wasn't too complicated, but it was made much easier. We took it down to a one variable type thing by substituting on r and just getting it in terms of h. Okay, next we've got a rectangle, and it's getting bigger. And it has a length that is twice its width. Okay, so I'll, make it kind of a long rectangle, not very wide. Okay, so I'll call that x and 2x. How fast is the perimeter growing? Okay, so we want dp dt. The width is growing at 5 centimeters per second. Okay, so they're telling us that dx dt equals 5. All right, so I need some sort of formula for perimeter. So I know that if the right side is 2x, the left side will also be 2x, and the top will be x. So I can say 2, 4, 5, 6 x's makes up the perimeter. So perimeter is equal to 6 multiplied by x. All right. Now I'm going to take the derivative of that with respect to time. It's equal to 6 dx dt. And I'm going to now substitute on dx dt, and that's 6 times 5, which is 30. Okay, this time the kind of similarity relationship was, instead of doing x and y and then substituting on y, just right off the bat I said, okay, length is twice its width, and so I just set it up that way. Made it a much easier thing. If we have just one variable that's changing on each side of the equation, it makes our life easiest. Okay, this next one is a cone problem, and for the most part, our problems that involve a right circular cone are going to have a proportionality relationship. So it's dumping sand onto a pile at a rate of 5 cubic feet per minute. Okay, that's a rate of change of volume. So dV dt equals 5. The radius of the sand pile is 3 times larger than the height of the sand pile due to the coarseness of the sand. A material scientist will understand. Okay, so I'm just going to draw kind of a scale figure. The radius of the sand pile is 3 times larger than the height. So this could also be 3h. Find the rate of change in the height of the pile when the radius is 4 feet. So I want dH dt. Okay, so I want to keep my h's and get rid of r, probably. So when the radius is 4 feet, that means that the height is going to need to be 4/3 feet. So first I need the formula for the volume of a right circular cone. So that's 1/3 area of the base multiplied by the height. And that's going to be given to you in the statement of the problem for the most part. I just didn't type it this time, it looks like. So I'm over here. I've got V is 1/3 pi r squared h. I'm going to just right now get rid of r, right? That's that substitution I need to make to get it down to just one variable that's changing. Okay, so I need to, say r equals 3h and substitute on that. I don't want to insert anything. I'm going to say V is 1/3 of pi. R is 3h, I'm squaring, and then I'm multiplying by h again. Okay, so when I square 3h, I'll get 9h squared. Another h is 9h to the third. When I divide by 3, that'll be 3 pi h to the third. Okay, so V is 3 times pi times h to the third power. Meaning that dv dt is going to be 9 pi h squared times the rate of change of h. Again, when r is 4, we have 3h equals 4, meaning h is 4/3. So this is 5 equals 9 pi. H squared is 16/9 times dh dt. Okay, meaning I've got 16 pi dh dt equals 5, or dh dt is equal to 5 divided by 16 divided by pi. Next, we've got a person watching a space shuttle launch. The person is 3,000 feet from the launch pad. Okay, so this will be the launch spot. This will be the person. And how fast is the distance between the person and the shuttle changing? The shuttle is 4,000 feet high. And rising at a rate of 800 feet per second. So I'll call that y, I'll call that x, and I'll call this r. The y dt is equal to 800. What is dx dt? 0, yeah, he's standing. So he's not moving towards the space shuttle. Even still, I feel like 3,000 feet from the launch pad might be an unsafe distance. But, you don't need to worry about that. Most importantly, it's 3,000, 4,000, so the distance at the time we're interested in is going to be 5,000, yes. 3, 4, 5 still works in terms of thousands. Don't worry. Okay, so r is 5,000, and dr dt is what we're interested in finding. Okay. So I'm going to go over here, and I'm going to say, well, what do I know to be true? This is a right triangle, so I know that x squared plus y squared equals r squared. So I've got 2x dx dt, and I know that's going to go away because dx dt is 0. 2y dy dt equaling 2r dr dt. Okay, so 2y dy dt is going to be 2. So actually, I've got 2 times 3,000 times 0 plus 2 times y is 4,000 times 800 is equal to 2 times 5,000 times the thing that we're looking for. Meaning that dr dt is going to be, 2 times 4 is 8,000 times 800. I'm going to leave that way and hope that maybe I can just cancel some stuff off and figure out the arithmetic. So I know it's going to start with 64, but it's like 6.4 million, 640,000, I don't know, 64 million. I don't trust myself with that type of arithmetic. So I'm going to divide by 10,000. And then I'll know that these thousands will cancel. And I'll have 8/10 of 800 will be 640. Okay, I trust myself with that. And r is going to be measured in feet, and time is measured in seconds. So I'm going to say feet per second. Okay, here we've got another problem with the same situation, right? The guy's still standing 3,000 feet away from the launch pad. Shuttle's 4,000 feet high, and it's climbing 800 feet per second. Now we're interested in the angle of elevation. Okay, so I'm going to draw the same diagram. We've got X, Y, and R. Okay, we know from the last problem that, okay, X equals 3,000. Y equals 4,000. R equals 5,000. We know the rates of change. dx dt is 0, dy dt is 800, and dr dt is 640. Not sure if we're going to need to use that. I don't really remember from last Thursday if we did. I think we do, though. And so we're interested in the angle of elevation from the person to the shuttle. That's going to be theta, where I marked it right there, that interior angle. Okay, so I'm looking for d theta dt. So there's kind of a number of ways that we could do this. We could use tangent with y and x, and I'm sure that would work just fine. We could also use cosine with x and r. Either way, I really want to use x. For sure. Why, though? There's 63. Yeah, because dx dt is 0. And I feel like anytime I've got something that's 0, I want to use that if I've got the choice between. I don't want to use sine, which will have y and r. You could get the same answer. It would just involve more arithmetic, which, as we know, is just more chances to make an arithmetic error. And we don't like that. Okay, so I'm going to go over here. I'm going to use, why not tangent? I think I used cosine last time, so I'll use tangent this time. Tangent theta is equal to y over x. But even better, because x is constant, I'm going to rewrite this. I'm going to say tangent theta is equal to y divided by 3,000, or 1/3000th of y. Yes, I like this. Okay, now I'm going to take the derivative of both sides. What's the derivative of tangent? Secant squared. Good. Secant squared theta d theta dt is 1/3000th of dy dt. All right, so I've got dy dt. That's going to be helpful. And I can figure out what secant of theta is. Okay, if x is 3,000 and r is 5,000, that means cosine of theta is 3/5, meaning that secant is 5/3. And dy dt is 800, so 800 over 3,000 is like 8 over 3. So what I'm going to do is I'm going to multiply both sides by 9 to get rid of that squared 3. That'll be 9 times 8 is 72. Divided by, okay, I'm going to have to divide by 25 to get rid of the square of 5. So 30 times 25, I think, is 750. And that will be in radians per second. All right, next we've got a ladder sliding down a wall problem, which is pretty common. Okay, we've got a 10-foot ladder. The fact of a ladder sliding down the wall is not common. That context for a calculus problem is quite common. All right, 10-foot ladder. Okay, I'm going to call that R, I'm going to call this X, and I'm going to call that Y again. This time dr dt is going to be 0 because the ladder is still 10 feet. The ladder is staying 10 feet. The length of the ladder is not changing. Okay, so I've got R equals 10, and the top of the ladder is 6 feet above the ground. That means Y equals 6. Okay, 6 something, 10, that's another 3, 4, 5. It's 6, 8, 10. So I'm going to get some rates of change. dr dt is 0. dx dt, let's see, the lower end is moving away from the wall at a rate of 2 feet per second. So that means x is getting bigger. So dx dt is 2. dy dt is, well, I don't know. That's probably what they're asking us for. No, they're not. They're asking the angle between the floor and the ladder when the top of the ladder is 6 feet above the ground. Okay, we don't have dy dt. So we probably shouldn't use y in our proportionality or in our trig relationship. So what I'm going to do is I'm going to use cosine here. I did that. Okay, so I'm going to use cosine for theta because we want to know about the rate of change of the angle. Okay, so theta is equal to, cosine of theta is equal to, what is it, x over r, which is going to be 1/10 of x. Now x is changing, right, because the ladder is sliding. So the distance is getting bigger. Meaning negative sine theta d theta dt is equal to 1/10 of dx dt. And meaning that d theta dt is going to be negative 1/10 of dx dt multiplied by cosecant theta. Now, isn't it interesting how we know that if the ladder is sliding down the wall, y is getting smaller. And the fact that the derivative of cosine is negative sine is going to take care of that negativity for us. I find that interesting. So this is going to be equal to negative 1/10. dx dt is 2. Cosecant of theta is 10 over 6. Okay, so I'm seeing negative 2/6 radians per second. Okay, now we've got a shadow and Walker problem. Okay, this one, I feel like you'll see it kind of on the old multiple choice, on the old free response in your packets, but I don't know, it's not bad. It's just another one of the types of related rate problems we can do. So a lamp post with height 20 feet. Okay, well, there we go. That's the lamp post. 5 foot tall person 10 feet away. And there we go. Here is the shadow. I'll call the shadow X. I'll call the distance from the person to the lamp Y. I'll give the lamp a little bit of, illumination. Yeah, it's a nice touch. And so what they're telling us is that the person's walking away from the lamp at 2 feet per second, meaning this distance is getting bigger. So dy dt equals 2. Okay. How fast is the length of the shadow increasing? Well, we want dx dt. Dx dt is what? Okay, so what you got to do, we also know that this is 20 and this is 5. What you need to do is you need to set up a proportion that describes the proportionality of the triangle defined by the guy and this angle, and by the larger triangle defined by the lamp post and that angle. So what I'm going to do is I'm going to say 20 over x plus y is equal to 5 over x. And then I'm going to cross multiply. So I've got 20x equals 5x plus 5y. And then I subtract 5x and I get 15x equals 5y, meaning y equals 3x. That's the way to go on this type of problem. It can get pretty complicated if we don't make some sort of substitution. Meaning that if I take the derivative of both sides, dy dt is equal to 3 times dx dt. And then all of a sudden it's like, wait, I know what dy dt. 2 is equal to 3 times dx dt, meaning that dx dt is equal to 1.5 feet per second. Okay, so this one, if you go down the wrong road, it can get really complicated. If you just set up, yeah, 2/3, thank you. Oh yeah, I see. Yes, thank you, 141. Okay, but if we go down the wrong road, it can get really complicated looking and nasty. So really, the key on this one is to set up this proportion and get a simpler situation. That is really going to be the way to go. All right, one more ladder sliding down a wall problem. Okay, again, this ladder is 10 feet long. This is X, this is Y, that's R. Okay, so 6 feet above the ground, Y is 6, X is 8. I'm going to put in the rates of change. How fast is the ladder coming down the wall? That's y prime, which is what we're interested in. R prime equals 0. X prime is 2. Okay, same situation as last time. We just want to know what y prime is. So I'm going to say, what do I know to be true between x, y, and r? X squared plus y squared equals r squared. So I'm going to take the derivative of both sides of this equation. 2x times the derivative of x plus 2y times the derivative of y equals 2r times the derivative of r. So I'm going to substitute on x and x prime. 2 times 8 times 2 plus 2 times 6 times y prime is equal to 2 times 10 times 0. All right, so I've got 4 times 8 is 32 plus 12y prime equals 0, meaning y prime is going to be, I'm not going to get fooled by this again, negative 32 divided by 12. Feet per second. All right, I actually got one more for you here. We've got water draining from a cone-shaped tank with a radius of 10 inches and a height of 25 inches at a rate of 3 cubic inches per second. Okay, I'm going to draw a little picture of this. It's looking like it's a cone. Assume it's a cone like this. Radius of 10 inches. Height of 25 inches. Draining 3 cubic inches per second means dV dt is going to be negative 3. What is the rate of change in the radius when the height is 15? Okay, when the height is 15, we're going to have to set up a proportionality relationship. Okay, so when h is 15, it's going to basically be, I'm going to draw this in red, it'll be basically this cone. Okay, so that means that this is 15, and we'll find out what the radius is at the time we're interested in. So I'm going to, kind of make that a proportion, and I'll say 10 is to 25 as 15 is to, no, 10 is the radius, as r is to 15. Okay, so that's 150 equals 25r, meaning r is 6. Okay, now we're interested in the rate of change in the radius when the height is 15. Okay, so I've got dV dt. I need a formula for v. That's 1/3 pi r squared h. We want the rate of change in the radius, so I need to get rid of h. Okay, so in general, I've got r is to h as 10 is to 25. So 25r is equal to 10h. And if I'm trying to get rid of h, I'm going to solve for h. So h is equal to 2.5r. Okay, now I'm going to go and I'm going to actually substitute that in. And so that's equal to 1/3 pi r squared times 2.5r. Okay, now I'm going to kind of clean this all up, and I'm going to have v equals, okay, it's going to be 2.5 is 5/2. So I've got 5/6 pi r to the third. And then I'm going to take the derivative. dV dt is equal to, 15 over 6 pi r squared dr dt. So if I plug in r, which we determined was 6, so dV dt is negative 3 equals 15/6 pi, r squared is 36 dr dt. So this is going to be negative 3 equals Well, that'll be 15 times 6, looking like 90. Therefore, dr dt is equal to negative 3 divided by 90 pi. And that's all I got for you on the more difficult related rate problems.